Steve by name, which you might already know. So we'll be covering some questions on physics for your Rhema for the SO student. So I'll be calling the questions and I'll be answering them one by one. I won't have much time to write those questions on the board, but I would definitely read it out so you can hear it, then we start answering the question. So let's go straight to the point. First of all, I'll be starting with motion. I'll be answering about 4th question on it. So motion now is has to do with the movement of your body from one point to another. Definitely you might already be familiar with the equations of motion, the three equations. Then motion is further divided into 2 parts, the one-dimensional. Okay, let me just explain with that on the map. The one-dimensional and the two-dimensional types of linear motion. So the one-dimensional is further divided into the normal linear parts, and the one that has to do with the fall of gravity. The fall of gravity is furtherly divided into three. The one that has to do with upward movement, downward movement, and also the one that has to do with horizontal fall of a body. So let me just do a glimpse of that. So if a body now, for example, an object is thrown upward, at the top, at this part, there's a point. If you throw like a broom to a particular height, on getting to that height, it will stop for a moment. So at that point, our V is equal to 0. And take note, when a object is going upward, whenever it's going upward, it's moving against gravity. So our value for gravity is always minus G. So our equation of motion, you know the normal equation, V is equal to U plus 80, V square is equal to U square plus 2AX, and S is equal to UT plus half GT square. So this half AT square rather. So this equation of motion, the normal linear equation, when it has to do with straight line, we then change its value, because this time it will be carrying a negative sign. When it has to do with upward, it will be carrying a negative sign. Then all the acceleration will turn to acceleration due to gravity, will be bearing the G value. To bearing the G value when it has to do with this case. So now, when it has to do with a body being thrown from a particular height, whenever you are throwing a body from a particular height, let's assume this is where you are throwing the body, is trying to come downward. At that height, its initial velocity is equal to 0. So for this one, upward displacement where our final velocity is equal to 0, this one will be, all this value they'll be equal to 0. Our V here will be equal to 0. So our U can be equal to GT. Our U square can be equal to 2GX. Because if you take this guy to the other part, take this guy to the other, this is what you'll be having at the end. This is when it has to do with upward displacement. Then downward displacement of a body when you are throwing the body downward. This formula will now, this time is moving together with the gravity. It will be having, our G will be having a positive sign. So we're having a positive value here. The G still remain present. Take note, our X at this point in time will be bearing our value for H. This is what our X is going to be bearing at this point in time. So that is that on that. Then horizontal displacement. All these ones are all one-dimensional type of linear motion. So for this one, when you are throwing a body from a height, it's being displaced towards this direction. The initial velocity is solely dependent on the S coordinate. That is, in your graph, if you are drawing your graph, we have the x-axis, we have the y-axis. So our initial velocity is solely dependent on the x dimension. So then, when the object is about landing, this value is called the range, or rather the distance it covers is called the range. This is the height. of which you all know about this. I'm just trying to brief us on everything. So the initial velocity is solely dependent on this, but the final velocity is dependent on both the vx square plus the vy square, both the x and the y coordinates. So let me start with my question so we can move further. So now for the first one, they say an object is fired from top of a building from the top of a 60-meter object. Okay, this is it. The height of the object is 60 meters. So it's being fired from the top. They said with a speed of 10 meters per second. The speed is 10 meters per second. Take note, the initial speed with which it was being fired is 10 meters per second. Take note, this one is not horizontal displacement of a body, that is, you are just displaying it horizontally. This one, you started from up. The body was first displaced vertically upward before it finally came down. So now, our initial velocity is dependent on both the horizontal and the vertical component. So now, at an angle 30 degrees to the horizontal, 30 degrees. So we're told to calculate the maximum height. The maximum height is the total height from here to here. You are calculating the both height in this case. So now, in your projectile motion, this one has to do with two-dimensional displacement of a body, two-dimensional, both in the x coordinate and the y coordinate. The formula for calculating maximum height is this value: u square sine square theta over 2g. Then our range, u square sine 2 theta over g. Then our time of flight is u sine theta over g, 2u rather, sine theta over g. So these are the formula for calculating any value on projectile motion you want to solve. But for this question, we're told to find maximum height. So therefore, our answer will be grossly dependent on the maximum height value. So now, our u in this case is 10 meters per second. 10, we square it, sine. My angle is 30 degrees. So if you solve this, you'll be having you'll be having 1.25 as your answer. So now, to get the maximum height which this projectile motion was being displayed, you have to add this guy and this guy together. Adding the two, h maximum is equal to our normal h plus the small h. So it will be 60, this height, plus 1.25. Adding it, you'll be having 61.25 as your value. So that is that on this one. So let's take another question on this before we call it a day. Let's take another question on this. Okay, now the second question, they said an object is dropped from an height to the ground in 0.5. So now, let me take it here. The object is dropped from an height to the ground level. I told you that whenever you are dropping an object from an height, its initial velocity is 0. This time, our acceleration due to gravity is acting together with the free fall. So our gravity is always positive. It has a positive value in this case. So that is that for that. Then we're told now that an object drops from rest to the ground. In the time taken for this motion, they said it was 0.5 seconds. An object dropped from an height to the ground is 0.5 seconds. We're told to calculate the height for which it falls. So we're told to calculate the height from here to here. We're told to calculate the height from here to here. Now, if you look at it, we are giving our time to be 0.5. We're giving G to be 10. Normally, G is not expected to be given. You have to have that in your head. I already know that our U is equal to 0 for this case because it's dropped from an height. So now, we are just looking for one value, the value of the height. So the equation of motion we'll be using is the third one, which is our S is equal to UT plus RGT squared. Our initial velocity is 0. Take note, S is equal to H. Our initial velocity is 0. So we'll be having 1/2 GT squared as your value. So now if you want to calculate the height, you said half. The gravity is 10. Time is 0.5. If you square it, at the end you'll be having 1.25 as your answer for this one. That is that under this one. So what I simply do is that the initial velocity was equal to 0 in this case. Then because the object is dropped from an height, and definitely if you are throwing something, if I want to throw this marker now from the top, I will have to hold it first before releasing it. So at that point in time, our initial velocity is 0. So now let's take the next question. So I wanted to bring a point to you that whenever two objects are dropped from an height at the same time and air resistance is being neglected, this is a law proven by, I think it's Galileo or something. Whenever two objects is being dropped from an height at the same time and air resistance is not present, in our real atmosphere of this world, that is like if you come outside from your building or your house normally, if you come outside, you notice that air is a resistance, or rather a friction that adds towards every single object or matter that exists on the earth's surface. So if we try to prevent a body from the existence of that friction, the air friction, and you release that body from a particular height and it's coming down, whenever those two objects, whether a stone and a feather, no matter the density of the object or the mass of the object, that is not to be considered. Whenever they are landing, they will land at the same time. That one is a point. It's most of the time an exam question. So that is that under that. Let's just shift to circular motion. So now, circular motion, this is the motion of an object about the whole of his body, or the turning around of an object, the turning effect of an object, the motion that exists due to the turning effect of an object. So normally in circular motion, there are some points you have to know. Whenever an object is moving in a circle, take note, it's moving in a circle, it's moving at one spot, its distance is just constant, it doesn't change. So its speed, take note, its speed at any point in time is constant. That is the distance traveled in a particular time. The distance it's moving in that particular time is always constant. It doesn't change. But the velocity, the direction, as it's taking this speed, there's a direction it's taking. The distance, the displacement taken with time, rather, or the distance traveled in a specific direction varies or changes at every single point in time. The value of it changes. It changes. So the speed and the velocity of the object always changes. Then that is one point I wanted to bring out. Then the work done by this body is typically 0, because the object is just on one spot, it's not moving. The work it's doing is not doing any work. Work done, normal work is expected to be done when a distance is being covered, but you are just moving on the spot, you are not doing anything. So that therefore tells us that the velocity of the body, the work done by the body is equal to 0, like I said. So the momentum of this body changes also. Just like momentum is mass times velocity. Momentum is mass times velocity. Based on the fact that the velocity changes, therefore the momentum also changes. So now let me bring out some formulas you need when solving circular motion. So whenever a body now is moving in a circular path, for example, this is the velocity. From here to here is a distance. Here is the radius. Here is the angular displacement. Our angular displacement s is equal to theta arrow. Our x is equal to theta arrow. This is a formula for solving the distance, or rather the arc it takes, the linear distance it takes. This is the radius, this is our theta. Our theta can either be in degrees Celsius or in radian. So if you want to convert it from radian to degrees Celsius, it's also possible. So another formula is our W, our angular speed, or rather our angular velocity. So now this angular velocity is equal to theta over t. That is our angular distance divided by the time. And our V is equal to W arrow. And take note, in some cases in circular motion, they might give you a question that requires you using your equation of motion. But this time, your equation of motion, you won't be referring the quantity, referring to the quantity you use during those time. That where you have to use your normal velocity, you have to use your acceleration and or those values in those cases. But now in this kind of case, you are expected to use your your quantity or values in circular motion. That is the equivalent of every single value you use in your linear motion. You are going to use it. You are going to use the equivalent of it in circular motion to solve. So now remember that our V is equal to U plus AT in linear motion, one equation. So now this case it will be W, let's call it W1 is equal to W0 plus our angular. I didn't brought to point the essence of our angular, the formula for calculating angular acceleration. So this is the formula, this is the value for it. So whenever you want to calculate angular acceleration, this is the formula you use. So now, then for the other equations, for the other one, our W1 square is equal to W0 square plus 2 alpha. Our S is equal to theta, the angular distance in this case. So now, then for our last equation, our theta is equal to W0t plus 1 over 2 alpha t square. So these are the formula you use. So now let's just take about two other examples on this case. Sorry, I'm a little bit fast, so you just have to try and grab every single part of it now. So now, for the first question I have here, they said a man drives his car around a circular track with a radius of 1,200 centimeters at 4 revolutions per minute. So now, the question said a man drives his car around the circular track with a radius. The radius is 1200 centimeters. Then we're told that the frequency is equal to so now frequency normally is the number of revolution a body takes. Normally, if a body is performing circular motion, the number of revolution it takes to complete one revolution is to turn around once, to move at an angle 360 completely once. So whenever it makes revolution, the number of revolutions makes with time is called the frequency. So normally, the formula for calculating frequency is n over t. This is the formula for it. So now we're given this question. So now the question now said we should determine the angular speed, that is our W. we should look for the value for our W. So now, for you to calculate the value for your angular speed, it's very simple. You just use our W is equal to 2 pi f. I didn't introduce this formula, but take note of it. Our angular speed is equal to 2 pi f. This is the formula for it. So now, 2 pi, we already know the value for our frequency to be 4 revolutions per second. So now, if you times this, 4 times 2 will give you 8. You'll be having 8 pi. Take note, our value of W is in radians per second. Whenever you are solving, your W value is always in radians per second. Then we're told after that to calculate the period. Period is normal, is written in this format T. We're told to find the value for it. Take note, under this part where our W is equal to 2 pi f, W is equal to 2 pi f. Take note, our frequency also is equal to 1 over T. Is the inverse of the period. Anytime you see your frequency is always the inverse of the period. So now, if I come here, I'll just replace it with this. So you'll be having W is equal to 2 pi over T. So now, look for the period from here. You'll be having, if you cross multiply, you'll be having WT is equal to 2 pi. So my T is equal to 2 pi over W. So now, using this to solve, let me introduce that here. T is equal to 2 pi over W. Already our W to be 8 pi. So it will be 2 pi divided by 8 pi. My pi will cancel my pi. 2 into 8 is 4. So we'll be having 1 over 4. 1 over 4 is 0.25. Period is always measured in seconds. So that is that under that for this question. So I have another question we can just quickly look into before I go. The one that has to do with the equation of circular motion. I have another question under this one. The one that has to do with the equation of circular motion. Please, I'm really fast. I have to do it so we can cover a lot on this. Well, at the end of this class, I definitely think we'll be ending in pressure or something, whether pressure or coefficient of friction. But let's just go. So the second question says a wheel start from rest. Take note, whenever it has to do with circular motion, our initial velocity is now the initial angular velocity, so it's equal to 0. So now, then I said, and it has an angular acceleration of, our alpha here is equal to 4.0 radians per second. So, we're told to calculate our angular distance, given that it made 10 revolutions. Calculate the angular distance when it made 10 revolutions. And if you remember, if you can remember if you could recap those formulas I dropped initially, you remember that I gave a formula like this. Our theta is equal to WT, W naught T plus 1 over 2 alpha T squared. I gave this formula. So now, the initial angular velocity is equal to 0. So therefore, the whole of this is equal to 0. We'll be having our theta is equal to 1 over 2 alpha T squared. Now, we're giving our value for alpha. We're giving the value for n. But we're not giving any other value again. And we're told to find theta. We're not giving the value for t. How will I now get my t? So now, remember that our W is equal to 2 pi f. And our W is equal to 2 pi n over t. If you can recap, I said our frequency is equal to n over t. So from here, our WT is equal to 2 pi n. WT is equal to 2 pi n. So now it made 10 revolutions. So I will say my WT is equal to 200 pi. So now this value for my WT, I can use it to solve this question, but we cannot use it to solve this initial one because we're just giving WT equals to 200 and we are not giving the value for T yet. Okay, now our WT is equal to 200 pi. And take note, I said our W is equal to theta over T. This is the formula for our W. Our theta here is therefore equals to WT. So now our theta is equal to WT. So if you will notice that our theta here is equal to WT, which is equal to 200 pi. Is also equal to theta. This value is also equal to theta. So now I think the question said we should determine the time, not the angular distance rather. So now if you want to determine the time, you already know your value for theta to be 200 pi. So you come here, you just place it. 200 pi is equal to 1 over 2 times. Our alpha is already given 4 t squared. So my t now will be equal to 200 pi times 2. Take this guy here, times it. If you multiply 2 by both sides, multiply 2 here, multiply 2, this one will cancel this one, you'll be having the 2 here. So it will be 200 pi. Then, to get the value for just your t, you divide here by 4. Take the square root of all of it. So my t will now be equal to the square root of 200 times 2 is 400 pi. 400 pi over 4. That will be giving you t equals to the square root of 100 pi. So let me punch my calculator and see what that gives me. At the end, you'll be having 17.73 seconds as your answer. So solving this is what you'll be having at the end of it. So now, I think I'm done for circular motion. I just want to give you a brief a recap of it, or just a little knowledge of every single thing. I'm not going to be touching everything that much. I'm just going to give you a cap on it so you get used to some of this stuff when you get to your exam hall, so it won't be like brick or frame. So let me check the next one we'll be taking after circular motion. Okay, I said I will take 2 questions on this. A wheel of radius 2.5 meter undergoes rotation. So now the radius of the wheel is 2.5 meter. They said it undergoes rotation at a constant angular acceleration of, our alpha was given to be 15 radians per second square. They said if its angular velocity is w is 2 radians per second. They said we should find the velocity, the linear velocity. We're told to find the linear velocity in this case at a time t equals to 2 seconds. So now, definitely from this question, they've already given you the first angular speed. So this first one is the initial angular speed. You already know already, and that is the initial angular speed. This is your angular acceleration. Here is your radius, and here is your time in seconds. But how can I get my linear velocity in this case? If you can remember our v, I gave you a value for it to be w arrow. So with this, you can use that to just get your value for the linear velocity. But first of all, you have to look for the value for your final angular speed or angular velocity. So now, to do that, you'll be using this formula. Our w is equal to w naught plus alpha t. So now, our initial velocity in this case is 2 plus our angular velocity is 15. Our time is 2. So this will be giving you 2 plus 15 times 2 is 30 now. It will be giving you 32 radians per second. This is the value for your angular This is the value for your angular speed, the final angular speed. Now, with this value, you can use it to determine the value for your linear speed. So our V is equal to W arrow. We already have our W to be 32. We apply 32 times the arrow, radius 2.5. So now, if you times these two together, you'll be having 32 times 2.5. Okay, you'll be having 80. So now this is the value for your linear speed. This is the value for your linear speed at the end of the question. So I'm just trying to make this fast. So I think the next topic we'll be going to is collision. Collision. So collision, with the word collision, you already have a glimpse of what it's trying to tell you, that this has to do with the meeting together of two bodies. When two stuff they meet together, there are some adiabatic people, you know, they will be thinking is some other things, but collision has to do with normal, let me call it two bodies. It can be a motor car and a motor car. There is an example of it is an accident. When they meet together, they might cause damage to themselves, or depends. That is depending on the quantity of force both of them are exerting on each other. So now we are not into the force and all those stuff, but want to just go basically into what that collision on its own is talking about. So collision is furtherly divided. Collision is branched into two parts. You have the elastic and the inelastic. So we have the elastic and the inelastic collision. So the normal difference between these two collisions is that both the momentum and the kinetic energy is being conserved. But for the inelastic collision, just the momentum is being conserved, but the momentum is being conserved, but the kinetic energy is not being conserved. So what I mean by conserve is that at the end of the reaction, there is no heat being lost. That is, for the elastic collision, at the end of it, there is no effect of heat being escaped to the energy being escaped to the atmosphere as air or something as heat. But for inelastic collision, heat is being given in the kinetic form. So normally, the elastic and inelastic collision, the formula for it is gotten from our Newton's law. Let me just quickly brand us on our Newton's law. Our a scientist gave basically three laws. He gave the first, second, and third law. Newton's law. The first one was that a body in the state of rest will definitely remain in the state of rest, except being acted upon by an external force. So a body that is just at this spot will just remain at that spot which it is, except it is being hit by another body. So is also known as the law of inertia. So the second law of motion, second Newton's law is that states that the second Newton's law states that the force is directly proportional to the change in linear momentum. That is mv minus mu over t. Change, the rate of change in linear momentum. Rate telling you time. So our F is equal to mv minus mu over t. Momentum is mass times velocity. So that is that under that. But the third law, which deals on this, basically this this collision we are talking about, is every action to every action there is an equal and opposite reaction. So if I rest my hand against this board, for this board not to have any crack on it is only possible if the force present in my hand is equal to that the board exerts on my hand. That is the normal reaction force the board exerts on my hand. So that is that under that. So now the equation for linear momentum is this. For the elastic collision, This for the first mass. It's first initial velocity and first. So definitely collision has to do with two objects, two body meeting together. I don't think anybody that has to do it more than 2, 3 or 4. Now, there are also collision, but those ones are more complex case. You can do it, you can just introduce it here. U1, U2, U3, U4, 4 bodies, 6 bodies, it depends. So now, then the kinetic energy is 1 over 2 mv squared, m1 v1 squared plus m2 v2 squared. Rather, m1 v1. No, this is u, rather. u1 u2 squared. Then the other one is half m2 v2 squared plus, no, v1 squared, rather. m2 v1 squared, and then 1 over 2 m2 v2 squared. Just like that. This is the formula for calculating elastic collision. Therefore, inelastic, it's almost the same thing as the elastic. It's almost the same. This is for inelastic. So it's almost the same thing as the elastic collision, but the only difference is that at the end of it, they share an equal value of their velocity, their final velocity. They share an equal value of it. So that is that under inelastic collision. Even the kinetic energy, the same thing. So they are sharing a common velocity. That is why I just introduce it as V here. So now this is that under elastic and inelastic collision. But there's something I want to bring to you. In case now you are solving and you come in contact with some certain questions that are very difficult, that they might they might give you just one value of this, and you might be finding one value of the velocity, and you may be finding some complicated issue on how to solve it. This is where you have to introduce your, but take note, they must give you the coefficient of restitution. The coefficient of restitution is what you can use to solve those kind of problems. The value for it is v1 minus v2 over, rather, v2 minus v1 over u1 minus u2. So this is the formula for coefficient of restitution. That is the formula for it. So you just imply it into it and you get your formula. So now, like I said, we are just here to just give you a brief cap on it, or so that if you get to your exam or you get familiar or used to this question. I just have one example under this collision stuff. But before doing that, in circular motion, back to circular motion, there's what I wanted to bring your mind to. So so there's something I wanted to bring your mind to. So in circular motion, normally between two bodies now that has mass m1, m2, there exists a force. That force was given by I think it's Galileo or something. The force that exists between two masses that that interact or exert a force towards the Earth's universal gravity. That force that exists between them is called the force of gravity, but it's given by this formula. This is the formula for it, for solving it normally. To get your force in this case. Then, but where your school focused on was just basically two parts. When I go through your textbooks, I saw it. So I just wanted to bring that to mind. So in case you come in contact with it in your exam. So now, is the velocity, how you determine the velocity? The velocity, the escape velocity is 2gm over r. This is the escape velocity. or V is equal to square root of 2GR. And also the period when it has to do with an object like a satellite. Whenever a satellite, the major satellite we have on the earth is just the moon, which you might be familiar with that already. But any satellite, whenever it's placed in an orbit, a parking orbit, whenever an object is placed, a satellite is placed at an orbit around the earth, for that body to remain at that orbit, there is the period, we call it the period with which that body exhibits. So this is the formula for calculating that period. Our T is equal to 2 pi square root of R over G. So when it has to do with the earth, it's GME. But take note, this arrow is in cube. So it can be equal to T is equal to 2. But based on the fact that we are dealing with an object, this is the center of the earth. The distance from the center to the circumference of the earth is the radius of the earth. So if a satellite is found somewhere around this place, let's assume this is the moon. From here to here, there's an extra distance. That distance is called the radius of this object from here to the earth. So if I want to introduce it to this formula, our arrow here will now be equal to arrow E plus arrow naught. So if you add it, you'll be having arrow E plus arrow naught all cube plus GME when it has to do with the earth. So this is the formula for calculating it. I just introduce this here so we can have a glimpse of all this when you get to your exam. We might not solve enough questions, but we are just trying to touch every single part on it. So now the next one we'll be dealing with is just one particular question I have on this collision I did. So let me read the question out. They said a lead bullet of mass 0.05. So the mass, the M1, the mass of the object is 0.05 kg. Is fired with a velocity, the U1 is 200 meters per second. So into a lead block of mass. So you are shooting a gun into a lead block. The block definitely is stationary. So you are shooting it. So the M2, the mass of the lead block, they said is 0.95 kg. Now the U2, the U2 being the final velocity, that is the velocity of the other object, the lead block itself, which you are shooting it into, is 0, because for you to shoot it into that body and the body is not exhibiting any motion or something, we're told to find their common velocity at the end. We're told to find the common velocity. That one has already tell you that what this question is trying to talk about. That one has already given you a glimpse of what this question is trying to talk about. It's trying to tell us to look for the common velocity, and definitely the only case where you find common velocity in collision, whether elastic or inelastic, is just in the inelastic part. So now in inelastic collision, the formula for solving it is M1 U1 plus M2 U2 is equal to M1 plus M2, or in bracket V. So now this is the M1, this is the M2, this is our V. So now let's solve. It will be 0.05 times multiplying it by our U1 200 plus U2 is 0.95 times 0 is equal to bracket 0.05 plus 0.95 multiplied by their common velocity. So now let's times this one. Let's see, this one definitely will give us 0. So let's times 200 times 0.05. 200 times 0.05. So giving me 10 at the end. So my 10 is equal to 0.05 plus 0.05 plus 0.95. So if you add that, if you add this one and this one, it will be giving you 1. 1 times v will give us v. So therefore, that tells us that our final velocity, or their common velocity, is equal to 10. So that is how you solve question when it has to do with collision. So now, when it has to do with question that has to do with equation of restitution, I don't know if I can formulate it from here. But let's assume the question we're giving v1, v2. We're giving v1, v2. We're giving the coefficient of restitution to be 1. So now, remember that for elastic collision, this is the formula for it: m1 u1 m2 m2 v2 plus m1 v2 plus so this is the formula for it. This is the formula for it. So now, assume we're not giving two values, these two values, the u1 and the u2, but we're giving these two values. So now, our first mass is 0.05. 0.05. Let me clean from here. So I want to try and show you a question that involves a coefficient of restitution. So now, times our v1 is what? Is unknown. Plus v2 is also unknown, but our m1 is 0.95. So how will you now get the value for your v1 and your v2? And we're giving the coefficient of restitution to be 2. So now, our E is v2 minus v1 all over u1 minus u2. I think so. So now our E is equal to 1. Our v1 is unknown, v2 is unknown. So I'll just place it v2 minus v1. So my u1 is what? 200. 200 minus 0. So at the end, we're having your v2 minus v1 to be equal to 200. If you cross multiply here. So we're having your v2 minus v1 to be equal to 200. So now this one, when I times it before, is like I got 200 times 0.05. That is 0.5 times 20. That is 10. 10 is equal to 0.05 v1 plus 0.95 v2. So we are having two equations here. So I can also convert this stuff I wrote here. This is my v2, this is my v2. v2 is bearing a positive sign at the front. Then our v1 is bearing a negative sign, is equal to 200. So now we are having two equations. This is when it has to do with coefficient of restitution, how you can solve it. So now, when you have gotten your value up to this point, this is already telling you that it's a simultaneous equation. How would you now solve it? You can use your calculator to do that. You can use your calculator to do that, to get this value. So now, definitely I won't be teaching you how to use your calculator in this case, but I think our other tutor have already done it. Your maths tutor has already taught you how to do it, but let me just take you this part. So now, 0.05, our first value, 0.95, second value, 10, then the other one, minus 1, 1, and 200. So now, when I solved it, my value for my v1 was minus 180 meters per second. Then my v2 was 20 meters per second. So that's what I'm trying to talk about. In some cases, you might be given a coefficient of restitution. At that point in time, they know that they didn't give you two values, or we're not giving two values for velocity. At some point in time, it can be u1, v2 that we're not giving. So it depends on the case, but just make sure you use your value for your coefficient of restitution, and then you use that to solve and get your answer. So now the next one we'll be moving to is The next one I'll be moving to is elasticity.